from the historical returns, so these are all simple average returns you have collected, you've calculated. You notice that between your portfolio P and the market that you're trying to compare it with, market has a higher return, all right, simple average return. Market does have higher return. But at the same time, what? Market has higher standard deviation, risk, total risk. And as Nick said, market always has a beta of 1. Market portfolio has a sensitivity of 100% to itself. So you can see market also has higher beta. So systematic risk-wise, total risk-wise, market risk is higher, but market return is also higher, right? So in this case, we need to calculate some performance measures because we can not really tell, at least just from looking at it, we cannot tell who is better, who is worse. One has higher return, but also has higher risk. Yeah, so here we go. Sharpe ratio. Josh, what do you get for portfolio P Sharpe ratio? What's your number?
I'm not gonna lie, I'm struggling getting there.
Okay. C, Tristan, what do you have for Sharpe ratio? 0.25, very good. Anybody else get 0.25 Sharpe ratio for P? Very good. So how do you do that? Well, pay attention when you plug in a number, it's just what? 9, and I'm being lazy here, I'm not using percentage because percentage, up, down, they can cancel. 9 minus 4, and then divided by 20, right? And that's 0.25. That is for P. Okay? So, same thing, 9% minus 4%, you have 20%, the percentage can cancel out, it's still 0.25. All right, for the market portfolio, what is the Sharpe ratio? Reveal.
I got 27.
Very good, and how did you do that? 10 minus 4, so don't forget parentheses and then divided by 22, right? So plug in the numbers, pay attention to the numbers, and then you get about 27. So just from Sharpe ratio, who is better? From Sharpe ratio, the market is better. Yeah, this one higher better, okay? That's from Sharpe ratio. Now, trainer ratio. Lawson, what do you get for P?
0.0625.
0.0625. Oh, yeah, okay, that's because you use the percentage. Very good. So 9% minus 4%. So Lawson is not like me, I'm lazy, Lawson is not. So 9% divided by 4%, and then this time divided by beta, right? Since beta is already positive, I don't have to worry about absolute value, and you get positive 0.0625. Very good. All right. Market portfolios trainer ratio. Nick, what do you got?
0.002.
0.002? Okay, let's look at it. Anybody different? Chloe?
I got 0.06.
0.06. That seems to be more along what I've got. So 10% minus 4%. This time, what is market beta? Market beta, Nick, you know that is 1. So that should be 0.06 exactly. Yeah? So, Nick, you got that?
That one is for the trainer ratio, or?
Trainer ratio for the market portfolio,
Oh,
right?
okay,
So market
okay.
return 10% minus risk-free return 4% divided by market beta always 1. So that's 0.06. So, as you can tell, so in the trainer ratio calculation, I did not omit the percentage sign. So if I do not omit percentage sign, I got to do it for every fund I'm comparing. So if I omit a percentage sign for one and did not, then it's not going to be right. But as you can see here, for trainer ratio, who is better? The portfolio, because it has slightly higher trainer ratio. Okay? All right. Just stop here for a moment. So, just because according to different measures, it gives you different conclusions, do not panic. Do not say, gosh, what's going on here? Okay, why according to Sharpe ratio, market is better, now according to trainer ratio, P is better. Why? Because they use different risk measurement, right? They adjust the same return, actual return, by different risk measurement. But why do they use different risk measurement? Well, it depends on your situation. Okay, so here is a good example. If the P that you're trying to evaluate, okay, if that P is your overall investment, that's all your money, okay? You have some 401k, you have some IRA, you have some 529, you have whatever, all of them together, and you're trying to figure out your performance and see if you beat or underperform the market. If P is your everything, then which measure should you use? If P is your everything. If P is your everything, then you should use measures that have standard deviation, your total risk, because that's your everything. You want to see how your return is adjusted by total risk. Okay, so far are you guys with me? However, if P, the fund you're evaluating, the mutual fund, the ETF, is just part of your overall portfolio, because in your overall portfolio, you may have 10 mutual funds, you may have 12 ETFs, okay? And you're looking at them one by one. So if that P that you're evaluating is only part of your overall portfolio, then use what? Measures that incorporate beta, the systematic risk. Does that make sense? Because you're diversified. Only the systematic risk matter for each component of your overall portfolio. Okay? So it depends on your situation here. If P here is your everything, use Sharpe ratio or anything that has sigma, standard deviation. If P here is just part of your well-diversified portfolio, then use the measures that has beta. Okay? Oh, you're just, okay. All right, next, Jensen's alpha. Anybody get the Jensen's alpha for P? Nathan?
Thing. So I got 0.0794.
That's not what I got. Nick?
I got 0.002.
0.002, that's pretty much what I got. So let's look at it together, okay? Nathan, I appreciate it. So Jensen's alpha by definition here is what? Is the extra return or the abnormal return that your fund generated versus what KPM said it should generate, right? So first thing first, you gotta plug in KPM. Okay? What is KPM? KPM says 4% plus risk-free plus what? Beta. Beta of my fund is 0.8. And then what? Times market return 10% minus 4%. So market return minus risk-free rate times beta plus risk-free. This is what KPM says my fund should generate, right? But what did my fund actually generate? How much? 9%. So it's 9% minus what KPM says it should generate. So don't forget your parentheses, okay? In your Excel, when you plug in numbers, same thing. So now this time, what do you get? 9% minus that, about 8.8%, so it's 0.2%. Yeah, Nathan, is that 0.2%? Positive, 0.2%, so slightly above 0, okay, 0.2%, that is for my P, okay? This is the definition of alpha. What your fund actually generated minus what it's supposed to generate based on its beta, systematic risk, according to KPM. All right, so that is Jensen's alpha for P. What about Jensen's alpha for market? Quick. What about Jensen's alpha for market? Does the market portfolio have an alpha? Carson?
I don't think so.
Very good, say it loud. Market portfolio has no alpha, it's market, okay? It doesn't have anything above what it's supposed to be, it's the market portfolio. So market portfolio also always have an alpha of 0, okay? So basically, if your fund has a positive alpha, according to the Jensen's alpha measure, they beat the market. If your fund has a negative alpha, then they didn't beat the market, okay? Everything got it? Very good. Everybody else, you got the 0.2% here? Good. Now that I know Jensen's alpha, what about the information ratio from CAPM? All I need to do is what? Using Jensen's alpha, 0.2% I just calculated, divide by, Evan, what do I divide alpha by? Divide, information ratio is always alpha divided by the tracking arrow from the same model, right? So tracking arrow from the same model here for P is 5%, so I just divide my alpha by 5%, and I get some 0.04, okay? That's for P. For the market portfolio, on the other hand, market portfolio has no alpha, has no tracking arrow, because it's market by itself. So really, market portfolio, you can't calculate its information ratio. It's not available. It's basically 0 divided by 0. It doesn't mean anything, okay? So far, you guys still with me? So these are the first 4, okay? Now let's look at the M squared P squared measure. So far, you guys good with the first 4, right? Market, P, they may give you different, like for example, if you look at Jensen's alpha, which one's better? Portfolio P is better, right? P has a positive alpha.
Where's that?
So, trainer measure, Jensen's alpha, both of them says, hold on a second. Yeah, trainer measure, Jensen's alpha says P is better, and Sharpe ratio says M is better, okay? All right, now let's look at M squared and T squared. So for M squared and T squared, we gotta do this. If you understand one, you will understand the other, okay? For M squared measure, what you need to do is you're trying to figure out a hypothetical portfolio from P and F. So it's much just like our capital allocation line here, okay? I don't know what my weight combination is, but I know the 2 weights will add up to 100%. I'm gonna form a portfolio P star. But when I form the portfolio P star, I want to make sure portfolio P star standard deviation equals to the market standard deviation, okay? And in our case here, market standard deviation is 22%. So I'm gonna select P and F in a certain weight so that P star's risk is the same as market risk, 22% standard deviation. So what is P star standard deviation then, guys? Do you still remember that from your exam 1? How do you calculate P star standard deviation? P and F at this much Y, at this much 1 minus Y, the whole thing is P star. Standard deviation of P star in this case only equals to Y times the standard deviation of P, right? Risk-free asset do not contribute to any risk. So P star's risk is just how much money you spend on P times P's risk. And what is sigma P? Sigma P, we calculate that. Sigma P is 20%. So really, to figure out the y, all I need to solve is solving 22% equals to y times 20%. Okay? And that, what is that y? What is that y? Y equals to 11 over 10, or 22 over 20. So far, you guys with me? What's 1 minus y? 1 minus y in this case is negative 1 over 10. So what does that mean? That means I gotta short sell risk-free asset by 10% of it, put the money I get from short selling plus my everything into P, and then I'll get a P star that has the same risk as the market portfolio, right? So far, you guys still with me? The y, the 1 minus y is just the two weights. Now that I get those two weights, 110% versus negative 10%, all I need to do is what? Plug in the weight to get P star's return. So my P star's return now is just gonna be weighted average return. You thought you were done with it, right? But you're not done with it. Portfolio return, always weighted average. So 1110 times P's return, what is P's return? 9%. Plus a negative weight is negative 1 over 10% times 4%. Okay? And what do you get? You get 9.5%. This 9.5% from P star, now you can see what the M square measure is. The M square measure is just P star's return. Oops. I don't know why it does this. Minus, I haven't even touched it. Market return. Like this. See if I can. M square measure is just P star's return minus market return. 9.5% minus 10% market return, and negative 0.5%. It's negative. Means what? Negative here means P star that's generated from P, the one you want to evaluate, P star, even though it has the same risk as the market, it falls short as far as return goes. Its return is lower than the market. Even though its risk, we make it the same as the market risk. Yeah? But where does P star come from? P star come from P, the one you're evaluating. So, P is not as good as the market. Okay? So here is a graph. The graph is required for your project, for your exam, so pay attention to the graph. Return always on the Y, risk always on the X, and this time the risk is standard deviation because we're calculating M squared. Yeah? Risk-free rate, 4% right here. That's your risk-free rate. Your P has what? Has about 9% return with 20% standard deviation. Okay, so that's your P. Your M, market, has 10% return with about 22% standard deviation. That's your M. Okay. So now, let's see where that P star is, let's see where the M square is. So the whole idea here is when you connect F and P, this is the capital allocation line. Remember connecting your risk-free asset and risk-key portfolio, right? And depending on how much you spend money, you can be half, you can be closer to P, or you can even what? Go above P, remember all that? So where is our P star? that's from P and F. We say our P star has short sale of F 10% and then 110% on P. So our P star is right here. Which means what? Which means we lined up P star with M so that P star and M has the same exact standard deviation, 22%. Yeah? But unfortunately, the P star that we created from our P, the one we try to evaluate, is below the market. Below the market means what? Means it's not as good as the market. So our M square measure, that negative 0.5%, the 9.5 minus 10, that is our M square measure for this portfolio P that we are trying to evaluate. So all we did here is because P and M has different risk, different return, and we want to line up their risk, so we created P star from P to line up the risk with the market risk. And once they line up, you can see who is higher, who is lower, and determine if your P is better or worse than the market. Okay? Questions? Nico?
How did you get again the 11 divided by
Very
2?
good. How do I get, that's the crucial, that's the key calculation here. How do I get that? Is because I make P star's risk equal to market risk using standard deviation as the risk measure. So market risk is 22%, that's given to you. Market risk is 22%. P's risk is 20%, that's given to you, or you can calculate it, that's your input. So for your project, same thing. Market, you can calculate standard deviation. Your phone, you can calculate standard deviation. So those are all inputs. So all you need to do is to set up your equation. Y times standard deviation of P equals market standard deviation, and then solve for Y. Okay? So in this case, Y is over 100%. Your ETF, your Y may not be over 100%. It totally depends on your numbers. Okay? Other question here. So according to M square measure, P is not as good as the market. Yeah? So far, you guys still with me? Now, if you understand M square's logic, T square is exactly the same logic. Everything exactly the same. Only that we're using beta, the systematic risk measure. So you're still gonna create a hypothetical portfolio P star from P and F, but this time you're trying to make P stars what? Beta equal to the market beta. Okay, so here we go. For your T square measure. So you're still trying to create a P star from P and F. You don't know what's your weight are gonna be, Y, 1 minus Y, but you know the two add up to 100%. But this time, what do you know is you're gonna make sure the beta on your P star that you generate from P is gonna be the same beta as the market portfolio, which, Nick, market portfolio always have a beta of? 1. Very good. So, what is the beta on your P star? Well, beta on your P star is just like the standard deviation of P star. The F, the risk-free asset, do not contribute to the systematic risk. It is risk-free. So all you have is Y times beta P. And beta P, you already calculate, that's part of your input. In our case is 0.8 times Y. So basically you're solving 1 market beta equal to beta P 0.8 times Y. Okay? So solving this little equation, what do you have? Y equal to 1 over 0.8, and that is what? 125, right? Which means 1 minus y is gonna be negative 25. So this one also involves short selling. You're actually short sell more. You're short selling 25% risk-free, just so that you can create this P star that has the same beta as the market beta of 1. Yeah? So far you guys still with me? And now that you get the y, you get the 1 minus y, all you need to do is what? Plug in the weighted average return again. So our P star is 125, weight on P. P is what? 9% plus a negative weight, so minus 0.25 times risk-free 4%, and what you get is a positive number. That is 0.25%. That is 10.25. Okay? And then you can calculate T squared as RP squared, RP star minus RM, and that's 10.25 minus 10%, and that is the positive 0.25%. So what does that say? According to the T-square measure, your fund is better than the market. Okay. So far, you guys with me on this calculation? Let's look at the graph again. So this time, return still on the Y, risk still on the X, but risk this time is a beta, a systematic risk measure. Risk-free rate 4% always here on the Y-axis, doesn't change, haven't changed. But your P is here. Return, 20% certainty. As you can tell, my graph is not proportional, right? 9%, 20%. I don't have a ruler to measure it. Okay. And your M, this part. M is somewhere here. Higher return, 10%. Oh, here it's not 20%, sorry guys. We're doing beta, so beta is 0.8. 0.8 P, and market beta is 1. Yeah, so this is beta. So now, as I connect F and P, this is my security market line. I connect it. In order to create the P star that has the same beta as the market, I have to go beyond P. And my P star now is what? Above the market. Yeah? So my P star and my market, they all have the same beta of 1. So I line them up with the same risk, but my P star is above the market portfolio. Above means what? Means that T-square measure right here is the positive 0.25%. So I generate P star from P, the one that I try to evaluate, so that it can have the same risk as the market portfolio. And, once it has the same risk, I compare the two returns, find out P star has higher return than the market. So as a result, I say P has better performance than the market, okay? So far, any questions? So that, this little calculations here, you're gonna do it in your project for each one of your ETFs, okay? But the inputs are already out there, right? Market risk premium, market what? Standard deviation, market beta, your ETF's beta, your ETF's standard deviation, it's all there. We just need to put them together. First step, always figure out the Y and the 1 minus Y, the two weights, right? And then you figure out the weights, and then you just calculate R P star, and then compare it with market. So, go back to our, sheet here. So according to M square measure, because our P has a negative, M square, so market is better, right? So this is negative, what, 0.5%. T square is a positive 25%. So market is better according to M squared, P is better according to T squared. So as you can tell, both the trainer, the Jensen's alpha, and T squared, so this three here give you consistent conclusion that your portfolio is better than the market. The Sharpe and the M square measure, those two give you consistent conclusion that, hey, market is actually better than your portfolio P. Okay, so far you guys still with me? Am I losing you? And as I said, the only reason for this seemingly inconsistency is what? Whether the P that you're evaluating is your everything, your overall portfolio. If that's the case, use Sharpe, use M squared, okay? Or whether this P is just part of your diversified portfolio. Then you only need to care about its systematic risk. Use beta. So use trainer, use T squared, use Jensen's alpha. Yeah? Questions? So I pretty much listed here. So Sharpe ratio M squared gave consistent conclusion. So in your calculation for your three ETFs comparing with the market, the ranking should be the same if you use Sharpe or you use M squared. And then the ranking should be the same if you use Jensen's alpha, trainer, or T squared. Okay? Between these two groups, the ranking may be different. But within these groups, the ranking should be the same. And that's what I mean there. Different situation calls for different groups of measures. Okay? So after today, you should be able to do most questions. I couldn't finish the nonlinear. So next time, Thursday, when we come here, we will finish the market timing part or the nonlinear regressions. And then you will be able to do everything. But now at least you can do all these different measures that I asked you to do. Okay? So I'll see you on Thursday.